All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have a lot of exciting lightning talks lined up for you. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants shares their knowledge on the evolving trends in the industry. That's going to help you keep learning and growing in your career. So this week, our iOS discipline lead Nader is going to give an overview of iOS design patterns, all the best practices surrounding it, and I'm looking forward to learn more about it. So without further ado, let's get it started, Nader.
Awesome. Thank you so much, Parag. And I'm excited to do this. So with that said, let's start. Can you see my screen?
Yep.
Awesome. So, as Parag said, my name is Nader Khraizat. I'm the iOS discipline lead with InRhythm. And, we like to bring in a lot of interesting topics so that we can kind of share the knowledge and share the vision of InRhythm with the broader team as well as with everyone else. So with that said, what I'm going to be talking about is the iOS design patterns. What are they and what do we need? Which one do we want to use? So with that said, what are design patterns? So design patterns are the way I look at them is the strategies that we use in order to solve common problems and write cleaner code in order to make something that's very complex within the mobile development into something that's leaner and easier to understand, easier to read. And so in other words, it is a template in order to help us write code that's consistent, clean, reusable, testable, scalable, and maintainable. And that's one of the things that the industry faces a lot, is we need to focus on making sure that we are building something that's scalable. And design patterns is what empowers us and what helps us to do those. So one other thing that they help us do is help us write loosely coupled code. That's one of the things that we're trying to avoid, is we want to make sure that each component is independent, right? And there's multiple examples of design patterns such as MVC, MVVM, which is model view model. MVC is model view controller. We have Viper. We have we have MVP, and there's so many other. So what do we choose? Well, I remember back in the day when I was working on a few MVC, which is the model view controller. One of the issues that we encountered is that within complex applications, and when the view has so many components, so many things that you're trying to do in that view, it just becomes so big. And I've seen some view controllers that kind of extended over 2,000 lines of code. And every once in a while, we do a cleanup, and then it keeps on growing and growing. So one of the things that came along is MVVM. And, just to kind of give an explanation of what is MVVM. So MVVM is the model view model. And this is where it gets interesting, right? One of the things that we're trying to do is we're trying to separate the user interface, which is what the user sees, from the model, right? So starting with the view, what is the view? So view is everything that the user can see. So it would be all the data that's displayed to the user, and any user interactions that the user is doing, such as tapping a button or typing in a text field, and then other gestures such as force touch or any of that. Now, the view is tightly coupled with the view model, which it needs to notify and be notified when data has changed. Moving on to well, I should have started with the model because it's MVVM. So the model it represents the data. And what we try to do is keep it specific to the data and the business logic within the application. So it's responsible for fetching, storing, performing calculations, or implementing some of the business rules. But it should be independent of the view and the view model components. So what that means is it shouldn't know if it's communicating with, an iPhone or a view or a text view or a label. It should be completely independent and just focused on the data itself. Now, this is where we kind of get to the kind of like the meat of this, which is the view model. Well, the view model is what acts as a bridge between the model and the view. So it's responsible to retrieve the data from the model, formats it the right way so that the view can display it and understand it. And then the view model also handles interactions for the user. So when the user clicks a button, then it will update the model and it would notify that there's been an update. So just kind of giving a quick diagram to talk about here. So as you can see, I don't know if you can see my mouse, I can't see it, but the view is completely isolated from the model. And that's intentional. And anytime that the view gets an update, it will notify the view model. And then the view model is going to notify the model, perform any changes. We're talking about a calculator, right? If the user clicks on 1 + 1, the view model is going to send it to the model. It will perform the calculation, and then it will broadcast it back to the view. So why do we want to use MVVM? There's multiple reasons why we want to use it. Well, one, separation of concerns. So when we have, with MVVM, it helps separate the business logic and data management from the user interface. That makes it easy to maintain and easy to test. Binding is the other thing. So here with the view model, it becomes the source of truth, where it allows the data to be displayed in the view, through reactive programming as well as other binding frameworks. Use of observables. MVVM is heavily reliant on observables. It makes it easy to observe any changes from the view model and update the view accordingly. Reusability. I think this is one of the big things that I see with MVVM, because unlike MVC, where everything's bundled up in one place, the view model allows you to abstract some of the business logic and the data from the view, making it easy to reuse the same model with multiple different views. And then this also empowers you so that if you change anything in the view or the view model, it won't affect the other. And we briefly talked about this, unit testing. Unit testing is one of the key things that we're trying to focus on. Is we want to make sure that we're not just writing code, we're writing quality code. And in order to ensure, one of the big things that we have to do is unit testing. And following MVVM, it simplifies things so that we can write unit tests for your view model, which contains the business logic. And then, yeah. Moving on to the next one. So here's one of the things that the industry has been thriving towards, right? What we're trying to do is we're trying to move into Swift UI as well as modern modularization. So that's why I want to talk about how MVVM works with Swift UI. So we've done some lightning talks about Swift UI, so I would definitely encourage you to go check them out. But to talk about what are kind of like the valuable or the integration that MVVM and SwiftUI provide for us. So SwiftUI allows us to integrate pretty easily with MVVM design pattern, because the view models can easily be bound to a view, providing real-time updates when any of the data changes. And if we combine MVVM with SwiftUI, it allows us to write the application to be easily maintained, testable, and scalable, because the two work together hand in hand, especially by using binding and observables. And then, there's also a separation of concerns that allows, to clear boundaries between different parts of the application. So making it easy to manage complex interactions and data flows into smaller components. And then, finally, kind of talking about, the modularization and how it works with MVVM. So MVVM is an architectural pattern. And, one of the things that we try to do is, as we're building complex application or big applications, we want to break them down into smaller self-contained modules or components. And this is, what MVVM does. So this makes it easy to manage and improve the performance of the applications, by allowing us to, by allowing the app to load and unload as needed instead of running everything together. And then, when combined with MVVM, the app modularization is going to create a well-structured, maintainable, and scalable application. And I have mentioned this multiple times just to emphasize on the importance of scalability, maintainability, and building the right architecture. And then, just kind of working with the presentation logic, right? So making sure that each component can be separated into a view model, which is responsible for processing the user input or accessing the data, updating the views. That makes it easier to test the logic and modularize the component and keep each component isolated. And that's what we're trying to do with modularization, and that's why the two fit together. So with app modularization, each component is going to be easily tested, and then that's going to improve the pipelines and making sure that when we're running tasks, things would move much faster. So overall, kind of like going in with MVVM, just working with modularization to work together in order to build something that's clean and independent, reusable, and just kind of clean architecture overall. So with that said, I kind of put on just really quickly a piece of code, and I just want to, it's nothing drastic or anything, but I just wanted to show a quick example. So let me share my screen. Let's go. Okay, can you see my screen?
Yep.
Okay, so just wanted to kind of show a quick overview. This would be, this is a calculator application. So what we have is the model. The model, as you can see, contains only the data, and then some additions. It's doing the calculation. So this kind of shows that the model does not have anything that's related to the view, or sending anything directly to the view. So it's completely independent. And then just kind of going to the view model, we've added a published variable here, and it just kind of watches for that change, and then it updates the view with any updates that happen. And then the view is just kind of showing just the here, like I said, I just kind of built something really quickly. It's loading, where it's just the calculator where it has the numbers, and it has the plus, minus, operators, multiplication and division. And what it does is it just shows the view. It doesn't do any calculation. It doesn't do anything. Its main focus is just displaying the user and any user interactions that do happen. Yeah, just wanted to show that real quickly. And back here. So that's kind of the presentation about what InRhythm is, and why it's useful and why do we need it.
Thank you so much, Nader, for such an excellent talk. As a reminder to you all, we do these talks every Thursday at 5:15 p.m. Eastern Time. And next week is a exciting talk. Ted Parton, who is our engineering lead at InRhythm, he's going to talk about gamifying the AWS practitioner certification prep. I'm looking forward to that. So make sure you mark your calendar for next week. Thank you all once again for joining. Have a wonderful evening, and I'll see you all next week.